Everyone, in this video we're going to talk about arithmetic sequences and also series that involve arithmetic sequences. An arithmetic sequence is a sequence such that there's a common difference between terms. Here's an example. See 5, 9, 13, 17, dot, dot, dot. Do you notice it keeps increasing by 4 between terms? There's a common difference between terms. 9 minus 5 equals 4. 13 minus 9 equals 4. 17 minus 13 equals 4. They're all common, they're all the same. And the difference is 4. So this is an example of an arithmetic sequence. Here's another example. This is not representing the sequence, but I wanted you to see that this notation here, a sub n equal to 2n minus 4. Recall a linear function, mx plus b. If this was an x, 2x minus 4. If you see a linear representation in the sequence, it's an arithmetic sequence. They're easy to recognize. 2n minus 4, or 5n minus 2, or 2/3 n plus 7. All right? That would be representing an arithmetic sequence. I mean, you might as well call them linear sequences. So, we're now going to talk about how you can sum the terms of an arithmetic sequence. Because there's a formula for it. There's a pattern to it. Got to be some kind of formula, correct? All right. Let's say there are here 500 terms here, and let's use 2n plus 3. And we're going to sum this up. Now this would take a long time if we worked this all out. Put in a 1, put in a 2, put in a 3. We'd have 500 terms we'd have to add up. There's a formula. Notice this is an arithmetic sequence right there. And there's a formula for summing the terms of an arithmetic sequence. Alright, so if you need to sum the terms of an arithmetic sequence, alright, the formula is n over 2 times the quantity first term plus the last term, where n represents the number of terms. Alright, here I'll put parentheses around that. So that's the formula that can be used to find the summation of the terms of an arithmetic sequence. I recognize that this is arithmetic, so let's use this formula because it would take too long that way. How many terms are there? There's 500 terms. Alright, there's 500 terms in this, so 500 over 2, which is 250. The first term is not a 1. The first term is what you get when you put a 1 in here. Alright, so if you put a 1 in there, 2 times 1 plus 3 is 5. That's your first term. Alright, be careful with that. Sometimes you just put a 1 there. It's the first term, and you substitute that number in here. The last term is when you put this number in here. So 2 times 500 plus 3. That would represent the last term, which is 1,003, right? 2 times 500 plus 3 is 1,003. And so this is 250. This is 5 plus 1,003, which is 1,008. And multiply these numbers, you'll have the sum. So we have 250 times 1,008, and we get 252,000. 252,000. 252,000. There. Didn't take too long. So you can use this when you know you have an arithmetic sequence. But if it's not arithmetic, you can't use this. All right. Here's another example. Let's say we have a stadium. All right. Leave that up there because we'll use it. And in the stadium, let's say it's just going like this. All right. Let's say there are 20 seats in the first row. All right. In the second row, there's 23 seats. In the third row, there's 26 seats, etc. All right. And there's a total of 38 rows. So there's 38 rows. Each time it increases by 3. All right, the next row would have 29, etc. Our goal is to find how many seats are in this section of the stadium. All right, we do have this first term. We know it's arithmetic because it keeps increasing by 3. So we can use this to sum up all the seats in that section. The first term will be 20. All right, there are 38 terms, so we got that. So we got this 38 over 2. We got the first term, which is a 20, but something's missing right now. What's this very last row here? I'll put a big question mark. How many seats are in that last row? Well, we can find this. Recall that in arithmetic sequence, right? It's like a linear function, just a bunch of dots. So we can use the linear formula, linear equation, you know, the y minus y sub 1 equals m times x minus x sub 1. This is the point slope form of linear equation, right? These are linear. So, what do I got here? Well, I got 2 points. In row 1, there were 20 seats. And in row 2, there were 23 seats. Okay? So, if I find the slope, 23 minus 20 over 2 minus 1, the slope is 3. X minus, I'll use this point right here, x minus 1 and y minus 20. Now I have a formula. This is 3x, right, minus 3, add the 20, I get plus 17. There's the linear equation representing this problem. And I want to know what's in the 38th row. So how many seats are in that 38th row? So 3 times 38 plus 17. That gives me 131 seats. So now I know, okay, there are 131 seats in this last row. I can take off this question mark. And I can finish up this problem, everyone. In that last row, there's 131 seats. There's a formula for this. There's a formula for finding this, but I always like to make the connection that arithmetic sequences are also linear functions. Okay? Just the dots, right? We're only putting in like 1s and 2s and 3s, etc. So, all we have to do is find that sum, we'll have the final answer. So 38 divide 2, that's 19, times, parentheses, 20 plus 131, and we get 2,869 seats. So the final answer to this problem, how many seats are there? There are 2,869 seats in that section. That's it.